So we are going to look, forget the section right there. We're going to start with problem set 19, and we're looking at number like 3 and 4. Is that what you're saying?
Well, 5 through 10. 3 and 4 I didn't have too many problems.
Oh, 5 through 10. Oh, okay. All right.
Finding that.
Gotcha. So when they give you the graph, it's not that hard to figure out, right? It's fine. The graph.
In the early lessons with finding asymptotes, when we first had them, I really didn't have any problem with it. But
okay. Let's start with an easy one first. Let's do number 5. It says f of x, so I'm just going to write y. Remember, he says that a lot. You can just replace y with the f of x. Now, the vertical asymptote is, it's where the denominator cannot be 0. Remember that? So this thing right here can't be 0, because if it was 0, what would y equal? 2 divided by 0.
Which is impossible.
It's impossible, right? It's undefined. It doesn't exist. Okay. So what we want to do, the vertical asymptote, is that spot where it doesn't exist. That's why they put the dotted line there, because your line can't cross that vertical dotted line. Remember that? So it's the place on the axis, on the x and y axis, or it's actually on the, goes through the x-axis. It's a vertical line where this does not exist. Right? So what we want to do is we want to take the bottom, the denominator, and then set it equal to 0, because this is where this line will not exist. Right? Now this is an easy one. They get a little more complicated, but it's the basic idea. So you take the denominator, you set it equal to 0, you find what x is, and that's your vertical asymptote. Right? So on this one, just add an x to both sides, so x is 4. So if I was to graph this,
wouldn't it be x is negative 4 because it's negative x, so you got to move the negative?
Well, you'd move the, I did it an easier way. I just added an x to both sides. So x is equal to positive 4. But if you got rid of this negative 4 and put it over here, then negative x equals negative 4, and then you have to get rid of the negative and then make it positive. Okay? But that way you kind of have to think through 2 steps. This way it's only 1 step and you're done. Does that make sense? So what you would do is, now what kind of line is x equals 4? Well, all lines are straight. That's a straight line, right? So if it's x equals 4, we have to know what kind of line is that. It's a vertical asymptote, remember, so that's a big hint. So what kind of line is it? It's a vertical asymptote. So it's a, what kind of line? A vertical line, very good. Okay, so that was a pretty good hint, wasn't it? All right, so it's a vertical asymptote. So that means it goes through 4. This is the x-axis, correct? All right. So it goes through the x-axis at 4. So if I was to graph this line, that line cannot go through, or it can't. It can't go through, or it can't be a part of this. Because what if x was 4? Stick a 4 in for this. What's 4 minus 4? It's 0. That means it doesn't exist, correct? So you cannot have a line that actually goes through here, because that, if it went through here, that would be a point 4 something. But if x is equal to 4, it does not exist on that line whatsoever. So that's your vertical asymptote. Now I did it in red, but they do a dotted line when they do the asymptote, but I just did a different color. Does that make any sense? Mm-hmm. Okay. So let's do one that's maybe a little bit more complicated than that one. Let's do 7. Okay. So you may want to make little notes to yourself. Vertical asymptote, you set the denominator equal to 0, and then you're going to get x equals a number. Okay, once you set it equal to 0, you solve for x, so you're going to get x equals a number, and then that's your vertical line. Whenever it's x equals something, like if it's x equals 3, it's a vertical line that goes through 3 on the x-axis. If it was just y equals a number, then what kind of line is this? This is a vertical line. What kind of line is y equals 3? It's a horizontal line. Okay? Remember that? So it's a horizontal line that goes through 3 on the y-axis. You okay with that? So it's very important to know what the equation of a vertical line is and what the equation of a horizontal line is for what we're going to do on these, for all these different asymptotes. Now, if it's a slant, do you remember the slant asymptote? It's going to be like y equals, I don't know, something x. Okay, that's what a slant asymptote would be, because this it has a y-intercept of 0, it has a slope of 3, and so that line is a slanted line. Okay? They're all straight, aren't they? They're all straight lines. But this is slanted, this is horizontal, and this is vertical. So if you know those things right there, that should really help you out, have a better understanding of what you're trying to find. Okay? So let's do 7. Again, it says h of x, but I'm just going to make it y equals. So it's going to be x squared minus 5 over x squared minus x minus 2. And again, it says find the vertical asymptote of this. So what do we do to find the vertical asymptote? Take the bottom and set it equal to 0. Exactly right. So we're going to go x squared minus x minus 2, set it equal to 0. And now we have to solve for x. So how are we going to solve for x here? Well, yeah, let's look to see if we can factor it. Now, sometimes you can factor, sometimes you can't factor. But I think this one we can. This is a fairly simple one. So what are we going to use here?
X plus 1, x minus 1. Or
well, if you had 1 and 1, it would multiply to be 1, wouldn't it? So it has to multiply to be negative 2 and add up to be negative 1. So here's your numbers you're going to use. What if you completely got stuck and your mind wasn't working and you could not think of what multiplied to be this and added up to be this? What's another way that you could have solved for x? It's a formula. I'll give you a hint.
Quadratic formula.
Quadratic formula. Okay, do you remember that? Okay, remember that? That's x equals negative b plus or minus square root of b squared. Okay. So you could use that if you wanted to. If you completely got stuck, right, and your brain's frozen, right, you're like, oh man, I don't know how to do that. You could always go to the quadratic formula. It's a little bit of an overkill for a problem this simple, but it always works no matter what. You can't always factor into nice, pretty whole numbers like this, okay? In this case, you could. Now, if they're both multiplied together and equal 0, what do we do with both of those?
We set them each one equal to 0.
That's right. We set them both equal to 0. So we set that equal to 0, and we set that equal to 0, and then we solve for x. Add a 2 to both sides, x equals 2. Subtract a 1 from both sides, x equals negative 1. Those are my vertical asymptotes. Now, they don't ask you to graph it, but I just want you to visualize what you're doing here. So x equals 2, and x equals negative 1. Right there, there's negative 1, and there's 2. So what does it mean to be a vertical asymptote? It's a vertical line that goes through x through those 2 points. So that's 1. Okay. Now this is not the graph of this equation, right? Yeah, these are the asymptotes, which means this graph cannot go through these lines, right? Right there. Okay, so those are your vertical asymptotes. Make sense? Yeah, the vertical is probably, well, I don't know if it's the easiest one, but yeah, it's fairly simple to understand. Alright, ready to do another one? Let's do one with the horizontal and the slant asymptotes. Alright, let's take a look at this one. Let's do number 8. It says m of x, I'm just going to say y again, equals x cubed over x minus 2 quantity to the 4th. Alright, so what we're going to do is look at the exponents, alright, to find the horizontal asymptote, or to find the asymptotes at all. Okay, you look at the exponents. Now, we could take this and multiply this whole thing out, and it would be some big crazy thing, right? It would be x to the 4th, then you probably have an x cubed, an x squared, blah, blah, blah. Whole bunch of stuff. But remember, you just take the lead one, the highest one. So the highest exponent, if you multiplied this out, is going to be x to the 4th. Okay? So if the top is smaller, okay, and this is, yeah, we'll just say that. If the top one, the top exponent is smaller than the bottom exponent, then the horizontal asymptote is going to be the y or the x-axis. And let me just do this so you can visualize it. Okay, so the asymptote is actually going to be the x-axis itself. But what's the equation of the x-axis? The x-axis is a horizontal line, and where does it cut the y-axis? Where does it go through the y-axis? At 0, doesn't it? Okay, so your equation, because it says, what's the equation of the asymptote? So you can't just say, well, it's going to be the x-axis. That's not really an equation, right? So you have to say it's going to be y equals 0. Again, what does that mean? This means it's a horizontal line, and it goes through the y-axis at 0. That's exactly what the x-axis does, isn't it? It's a horizontal line, and it goes through the y-axis at 0. Make sense? So you don't even have to do any math or anything. All you got to do is look to see, is the exponent smaller on the top than on the bottom? If it is, then your horizontal asymptote is the x-axis, which is y equals 0. All right? What about, let's do 9. We'll go 9 and 10. All right? Might as well hit all these. Is this helping at all? Okay. It really is nice if you keep it straight. You might even want to put in your notes somewhere, like keep a little chart, you know. This is how I do vertical asymptotes. This is when the horizontal asymptote is y equals 0, and then, you know, right in there when the numerator of the exponent is smaller on the top and bigger on the bottom. And then the next two we'll do, and you might want to write those down. Just write them down so that you understand it, you know what I mean? So this is going to be 2x over x plus 3. Now again, we are looking at the exponents. Well, the exponent to this is 1, isn't it? The exponent to that is 1. We forget all the other stuff after it. Okay, don't forget the coefficient, but if like something's being added to it, just forget about that. Right?
The ratio.
Exactly. So this is going to be 2x over x, isn't it? When the power on the top is the same as the power on the bottom, look what happens. They cancel out, don't they? See what happens? So the x cancels out with that x. So you're just left with 2. Y equals what? 2. And what is, we'll just use this graph up here, what is y equals 2? What kind of line is it? It's a horizontal line that goes through where? The y-axis at what? That's 1, and that right there would be 2. So that would be your horizontal asymptote. That means if I was to graph this line, that line's not going to cross this red line right here. Okay, it won't touch it, but it'll approach it, right? It'll, whatever the graph looks like, it'll approach it, and it'll get really close to it, but it's not going to hit it. Okay? Okay, let's actually graph this just to show you what it looks like. So it was, oh, it's the 2x, right? I forgot which one we're doing. So it's going to be 2x over x plus 3. Alright, and we come over here and we plot it, and it's a little bit blown up. Let's go, let's get a little smaller. If you look at this bottom right here. What does it approach? Oops, let's get bigger. See, there's 1, and there's 2. Look, it gets, the more I scooch it over, it gets closer and closer to 2, but it doesn't touch it, alright, and it won't go through it. You follow me? So that's the horizontal asymptote, and look at this one. This starts from the top and it goes down, but look where it gets closer and closer to. It gets closer and closer to y equals 2. So now on this particular graph thing, they don't actually write in the horizontal asymptote. It'd be nice if they did. They don't, but that's okay. But we can see that it approaches 2, but it never touches it. See that? It gets closer and closer to 2. This one gets closer and closer to 2, but it never touches it. So that kind of verifies that what we did right here is correct. Make sense? That's why it's nice to have that graph. And that's a little easier than the graphing calculator one, isn't it? That graph right there. Download it if you can. If you haven't done it, I would suggest downloading that. It's what is it? Calc X. Right? Just type that in your browser, and it's real quick download. I mean, downloads in a second. It doesn't take much memory, and I haven't had any trouble with it at all. So it's just kind of nice to make sure you know you're doing things right, even if they didn't ask you to graph it, and they don't on these, do they? They don't ask you to graph them. They just say, what are the asymptotes? All right, let's do 10. And let's see, y equals x squared minus 4x plus 1 over 2x minus 3. All right, again, we're just looking for the exponents, aren't we? So let's take a look at this. That exponent, we'll forget all this stuff right here, we'll forget all this stuff right here. And he gave a pretty decent explanation of why we forget all that stuff, but let's just not worry about it now. I mean, what's the exponent to that one? It's a 1, isn't it? So what do we have when, let's write this out without all the other junk, all the stuff I scribbled out. What would we get? We get y equals x squared over what? 2x. Now look what happens here. One of these x's cancels out with one of these x's. Do you see that? 2, right. So do you see that? One of these right here cancels out with one of these, and so you're left with x, or y equals x over 2. But let's write it a little bit better. Let's write it so it has a coefficient. X divided by 2 is the same thing as writing 1/2 x. Would you agree with that? And that's it. That's your asymptote. Now, what kind of asymptote is it? Is it a horizontal? Is it vertical? It's a slant, right? Because remember, this is just a straight line, isn't it? So it means you have a y-intercept of 0 and a slope of 1/2. Rise 1 and run 2. See that? So let's put that into our calculator and see what that looks like. And we'll put it in here. So let me put the top in parentheses. So it's going to be x squared minus 4x plus 1 minus 4x plus 1 divided by, and then put that in parentheses, 2x minus 3. Close the parentheses, and let's plot it. Now look at this. Look at the asymptote here. What did I say? I tell you what, I think, can I do 2 at the same time? Let's do that. What did we say the asymptote was? Y equals 1/2 x, right? So, let's put 0.5. Make it easy. I think I can put them both on the same. Alright, why isn't it there? It should show up. It should go. Hold on, let me try something. Okay, there we go. There's our asymptote right here. Now, he does give an explanation. I don't really have a good explanation for this because this does actually go through this asymptote, doesn't it? You see that right there? I just can't explain it. He does go through it, and when I was listening to his explanation, I think he was fudging just a little bit, you know what I mean? He was like, yeah, I don't know if he exactly knew, but look what this does. See, it's the asymptote. It looks like it's parallel to it, but it actually gets closer and closer. Now, very, very slowly it gets closer and closer, but that is your asymptote. So that's a little bit weird, but that's what it is, okay? So there we go. So now we know how to find a slant asymptote, a vertical, a horizontal, and we know how to find a horizontal if it's not on the x-axis. We know how to find a horizontal asymptote if it actually is the x-axis. Okay? So that helps a little bit? Right. Yeah, that stuff was a little confusing. That stuff you never did in Algebra 2. Would you agree with that? I never taught it in Algebra 2, so yeah, it's a little different. All right. And that should help you with quite a few of the other lessons, too, because they threw that stuff on there in the other lessons as well, didn't they? Right? So, good. All right, what else we have? All right, so what we're going to do is, actually, let's push this off to the side. We are going to graph y equals x squared plus 7x plus 10 over x plus 2. All right. And let's see how we're going to do this. It says you can use a calculator as a tool, but then put your final graph on paper. But we'll just look at it on the calculator. All right, so let's plug it in. So we hit y equals, and we hit x squared. So x. Now he always hits this up button. Yeah, you're right. You're absolutely right. Let's do that. Good call. Okay, so it's going to be x squared. You could just hit this x squared button, hit an x, and then hit the squared button like that. Yeah, he always hits the up thing and then the squared, which is fine, but you know, you can do that as well. Plus 7x plus 7x plus 10. Close the parentheses, and it's divided by, I'm going to put the bottom in parentheses as well, since it's a sum, x plus 2. X plus 2. And close it. Alright? And let's graph it. Let's just see what it looks like. So it looks like a straight line, doesn't it? But like you said, what did you say? Go to...
I'm going to table, so you click the yellow button, and then under trace or
Trace.
No, it's graph.
It's graph, right? Because it's hard to read right there, but that does say table. So you hit the second and you hit table, and
I
if
think
you
it's negative for the error.
okay, well, yeah, there it is. See, it's -2. Now, you could have figured out that -2 is where your error is going to be anyway. How could you do that just from looking at this equation?
Number on the bottom is +2, so you can't have a negative.
That's right. You can't have a -2. So what could you do to figure that out without actually looking at the table? You could set this equal to 2. It's kind of like that asymptote thing, right? So it's going to be x equals -2. So it's not really an asymptote because this isn't necessarily a rational function, because you could probably divide this and get one thing, right? This is just you could do a simple division here and just get one not equation, I guess you can call it equation. So you can actually turn this where it's not into a rational function. That's why you get the straight line graph. So at -2, you don't really see it here, but at -2 there would be a hole right there. And the reason that there's a hole, because if I put a -2 in for this, then -2 plus 2 is 0, and that does not exist. You follow me?
Mm-hmm.
So you could have put a vertical asymptote, right here, and that means it goes really, really super, super close, right, to that vertical line, but then it just jumps over it, right, and then it starts again, right? So you could have anything just a little bit bigger than -2 and just a little bit smaller than -2, but you can't have -2. Yeah.
You put like very,
Right, and then you put the
very
numbers
close.
in there. Yeah, yeah, exactly. Okay, so that's basically how you do that. So if you look at, they give you choices here. So
And then it looks like a D and E, and then E is negative. I mean, D is -3, and E is -2.
yeah, so if you put a -2 in for this, let's see, is it, oops, turn it off. Okay. Let's see. Okay, so what we're going to do is we're going to take that -2 and put it in here and see what we get for y. Now this is going to be undefined. I don't know, I'm just curious to see what happens. Because you want to find out where, at -2, where is that hole, correct? So let's just see. Anyway, put a -2 in there, that's a 4. Oops, that's a 1. Put a -2 in for this, that's a 4. Put a -2 in for that, that's a -14, right? And then plus 10. No, it's not going to work, is it? So that's -10 plus 10, which is 0. Let me think about this. Alright, I think the best way to do this is just to hit the table function like we did earlier. So hit that, and if you look at this, at -2 there's an error, so that's where your hole is going to be. That's probably the best way to find out where the hole is. Right? And if you look at the graph, it's at -2, 3, because watch, 0, 1, 2, right? And then there's nothing there, and then it goes to 4, so that's where the 3 would go, but it doesn't exist, right? -2, 3 doesn't actually exist, but that's where the hole would actually be, where it doesn't exist. All right, I think that makes sense, don't you? Mm-hmm. Yeah. All right, so now what are we doing? We're doing, oh, I lost the page number already. What page was that? Yeah, that same problem. What page was that on? It was 20. Oh, there it is, page 203. All right, so we are doing, we're doing page 203, which is what, problem set 20, and it's number 23. Okay. So roller coaster going over a hill. So here's my full roller coaster. There's the ground, and then roller coaster goes like this over the hill, and it says it's going to reach a speed of 80 miles per hour. So when it goes down, it says an increasing rate to reach a speed. So look, as you're going up the hill of a roller coaster, are you going faster and faster? Well, actually, I guess you do kind of have to go to a speed, but you're going to really increase from here to here. I don't think you're going to reach 80 miles per hour at the top of the hill. Except if you're in those one rides. What's that one ride at Great Adventure? You ever go there? It's like a Batman, or it's Superman, I think, and they take off super, super fast. But they shoot horizontally, but then you go up the hill and you actually do start decelerating. Is that what it is?
I just went there.
Oh, okay. So right here, your velocity is 0, and right here, your velocity is 80 miles per hour. So that's basically what's going on. And then they give you the equation for the velocity at a certain amount of time. So the velocity at a certain amount of time is this equation right here. And what you're trying to do is you're trying to find out how many seconds is it going to take to reach that speed. Now right here, your velocity, I'll put V for velocity, is 0. You're talking horizontal velocity, not vertical velocity. I'm sorry, the other way around. You're talking vertical, not horizontal velocity. Right? So the vertical velocity would be 80 miles per hour here and it would be 0 here. And this is the equation. So what does this represent? This represents the velocity or the speed at a particular time. Right? Well, we're trying to find out how much time do you get at 80 miles per hour. So the 80 actually is this. That's the speed, right? Velocity. So you put an 80 right here. Of course, what does the T stand for? That's the time. That's right. So this is the time that it takes to get to 80 miles per hour. If this number was bigger, this time would be a bigger number. If this, right, because it would take you longer to get to a faster speed. Would you agree? Mm-hmm. All right. So that kind of, hopefully that makes sense. And then you just solve for T. So you subtract 4 from both sides. That'll give you 76. You divide by 6, and then you'll get rid of that. Then you take the square root, and it'll give you that. Once you put that into your calculator, I already got it in there, 3.559. It says to round it to 2 decimal places, so the 9 rounds the 5 up to a 6, so it's 3.56. And that's in seconds. So it takes 3.5 seconds to go from here to here. Okay? Yeah, yeah. Where you go like way up. And, yeah, that's crazy. That's awesome when you first start off on that thing.